Hey everyone, how are you doing? Here's a video from my Algebra 2B class for the week 4 Desmos activity over rational functions. This one's going to take a while for you to work through, and I really want you to dig in, exploring graphs, understanding vocabulary, and thinking about how we can put together the right function that models what we're trying to do. So I'm going to go over some examples here to help you get started. On slide 1, it's all about vocabulary. So I want you to do some thinking about slant asymptotes, do some research if you need to. You have a lot of methods. So set canceled factors to 0, compare degrees of numerator and denominator. And then you have some other vocabulary. I want you to try and match things up. So it might be easiest to take things like a hole, horizontal asymptotes, vertical asymptotes, slant asymptotes, y-intercepts, and zeros. There's 1, 2, 3, 4, 5, 6 things. And then you have 6 things left to figure out, well, which method do I use to find these things? So we know a hole is what happens when we have a canceled factor equal to 0. So a hole is going to happen when I set canceled factors equal to 0. So I've got a match there. You're going to do the same thing. Well, you'll have to think through a little bit. But there you go, vocabulary in the first slide. Then you get into some exploration with vertical asymptotes, looking at graphs. You're just going to fill in, identify. You can click on any of the graphs to see. So here's a vertical asymptote when x is 3. So one is going to be x is 3. And then there's the other one's going to be when x is 1. All right, got both vertical asymptotes. A horizontal asymptote is going to be the horizontal one. You can see right there happens when y is 3. Gonna fill it in. So I'm just going to move my way along. The slant asymptote, again, you have this line. You just need to come up with an equation. There's the y-intercept. You have another point, so you can find the slope and find an equation of that green line. But let's move on. So I'm going to move out here. And particularly, I'm going to do this one because this one tends to be a tricky one for students. Write an equation to match this function. All right, so notice it's giving me the vertical asymptote, the slant asymptote, and then it leads me to getting to the function. So I'm going to go each of those step by step and walk you through how to build a function for this one here. Also, I want to point out there's a 0 when x is 0, y is 0. So that's a key point that I'm going to use and refer to as well too. All right, so let's get the vertical asymptote. This happens when x is 1. So I'm going to use that in forming my equation. You can see there, the line turns blue. It's good. The slant asymptote here has a y-intercept of 1. And when we go over 1, it goes up 1. So slant asymptote is going to be y equals 1x plus 1. So pretty basic equation. I can see I got those formed right there. Those are actually going to help me come up with the equation that I need to form the line. So now we need to figure out the actual function. We've got a vertical asymptote, we got our slant asymptote. To figure out the function, we have to work our way backwards. In general, to find the slant asymptote, I take my whole numerator of the function and I divide it by the denominator. However, I know my denominator is going to be x equals 1, x minus 1. So let's start filling in what we know. I have to have x minus 1 in the denominator because the vertical asymptote is 1. If I put 1 in for x, I should get division by 0. So there's filling in a little bit there. So the numerator, whatever's on top of my function, has to divide by x minus 1 to give me this function. So I need to have an x minus 1 to divide out, then to leave the x plus 1. Okay, so we're kind of filling in, and now you're like, this is not even close, Mr. Close. It looks like a line because my x minus 1's divide out. So here's where we still need to figure out. So right now, this numerator would divide by x minus 1, and it would give me this line, which is good. But when we do that, we also ignore the we ignore the remainder. So here's where I have to use that point when x is 0, y is 0, and I can work backwards. So if I put 0 in, let's do this here now. If I put 0 in for x, I need to have 0 minus 1 times 0 plus 1 over 0 minus 1. And whoops, I need to put 0 in for x. Notice right now that equals 1. But in my function, when I put 0 in for x, I have to have y be 0. So instead of having it equal 1, let's subtract 0 or subtract 1. Whoops, let's add 1. There we go. Now we've gotten it equal to 0. And now let's add 1 in the numerator of my function here. So there's going to be the remainder piece. And look at that. Let me change colors to make it more obvious. There we go. There is a function that matches right on the blue line. So again, we found the vertical asymptote, gave us the denominator. The slant asymptote gave us part of the numerator. We needed the bottom part because they have to divide out. If I divide all this numerator by the denominator, it's going to divide out. But there's my remainder of 1 that I had to have to make it equal 0 and to get this actual point. So I used one of these points to make things work out. All right, so it's going to take some work. It's going to take some algebra and some thinking for you guys, but hopefully that helps you get you started on this week 4 activity.